Today we're going to take a look at distribution and evaluating expressions. This is something we've covered in Algebra 1. It's been a while since we've possibly looked at these, so we're going to take a look today. So these examples you're going to see are all on the Delta Math assignment called Distribution and Evaluating Expressions. So go ahead and pull that up if you have not already. Before we get into that, what we're going to do is rewrite some of our algebraic expressions as equations, or just algebraic expressions, words into numbers. All right, with a number being represented by the letter X. All right, so this equation says the sum of, anytime you see the sum of, we obviously have adding. You're going to have a number or letter and then the word and. And the sum of is going to be the phrases or numbers surrounding that word and. So the sum of 4 and the cube of a number. And again, a number is going to be represented with the letter X. So the sum of 4 and a number cubed would be 4 plus x cubed. All right, so as we look at this, it's the same process, just a little more difficult question here. And we want to focus in on the word and. So it says 6 is being multiplied by, okay, that's the expression that's happening. And then the word and is going to separate the two things that are being multiplied. So it says 6 is being multiplied by, there's our parentheses, the difference of 5. Difference is subtraction. So the difference of 5 and a number, which we've already established is the number X. So our expression would be 6 parentheses 5 minus X. Now we're into distribution. Remember, parentheses is a form of grouping. And anytime we have something that is grouped, whatever happens to one term has to happen to all terms. So in this case, we are multiplying each term inside of our parentheses by 4. We're going to swing that in there, and everything is being multiplied. It's very important as we do this that we pay attention to the signs in front of numbers. Remember, numbers are associated with the sign directly in front of them to the left. So 4 times 10 is 40, and then we're just going to tack on the n. Then we move to the next. We have 4 times negative 7. Well, that would be negative 28. The 7 had a p, so we have 1p. Remember, when we multiply variables, their exponents accumulate, so they will go up as we go through. And then lastly, 4 times 10 is 40. These are not like terms. Remember, to be like terms, you have to have the same variable with the same degree. Degree means power. So here we have a distribution that involves both distributing a negative sign and distributing a variable. So we are distributing negative 9x to everything inside of the parentheses. So if we're distributing a negative term, all the terms inside are going to change to the opposite. So if they were positive, they'll turn negative. Negatives would turn positives. Negative 9 times 5 is negative 45. And x times x, well, this is where we start accumulating those as powers. This would be x squared. And then we distribute our negative 9 to the 3, which is negative 27. And then we have 1x between the two of these. One way to check your answer real quick anytime you're doing distribution, the degrees between these two are off by 1. After distribution, they are still off by 1. If that changes, we have a problem. Really, This question is probably easier than the previous one because we are distributing a negative, we're distributing a variable, but we do not have a coefficient. The reason why we chose this one is because it is different in that we are distributing to 3 terms. We distribute to everything inside of the parentheses. So we distribute the negative sign to the 9, which makes it negative 9. X squared times x makes this x cubed. We've accumulated 3 x's at this point. Negative x times negative 3. Well, negative 1 times negative 3 is positive 3. They both bring an x to the table, so we have accumulated x squared, 2 x's. And then lastly, negative x is going to multiply times negative 8. We see another sign change. The 8 does not have an x, so we will just have 1x when these 2 terms are put together. And then you can double check those powers, like I said. This went 2, 1, 0. Now it goes 3, 2, 1. So they are off by 1 each way. So that's always a good sign. Doesn't mean it's right, but if they do not follow that correct order, then it's definitely wrong. So we're going way back on this one. I just feel like we need to touch on this. We are adding terms. These are combining like terms. It's very important that we recognize the only way that the exponent changes is with multiplication, division, or a higher level math, square roots or powers or anything like this. When we add these g's together, we are not changing the degrees of the g's. What we have is 1, 2, 3, 4, 5, 6, 7 g's. This is not g to the 7th power. This is 7 g's. And then as far as our h's go, we have 1, 2, 3 h's. This is not h to the 3rd power. This is 3 h's. So 3h. All right, as we take a look at this simplifying expression, we have like terms. We will have like terms in just a moment, and we have distribution. It's very important that you follow your order of operation, GEMDOS, PEMDOS, however you were taught, grouping, exponents, multiplication or division, addition, subtraction. So the first thing that falls in here, we have grouping, yes, but there are no like terms within that grouping. There are no exponents. So the first thing we actually see is multiplication here. And we are going to multiply 7 to everything inside of the parentheses. So 7 times 2 is 14 with a t. 7 times 9 is 63 s. We did not use the 4s, so the 4s is just going to carry down. And now we have created like terms. Now do not try to subtract this 4x over. A lot of times I'll see students that try to get things to the same side like they were solving an equation, but this is not an equation, and even if it was, these 2 terms are on the same side. So we don't have to do anything special to combine these terms. We just combine them. They would be 67s plus 14t. Last thing we're going to look at is evaluating expressions. Remember, variables are used to denote unknown numbers. Well, this is one of those where we had an unknown number, z, and then we come back and we learn that z is equal to 2. So this is no longer an unknown number here. These are just numbers, and we're going to substitute this back in. Now, I searched and searched through Delta Math trying to get an input value of a negative term, but I couldn't find it. So hopefully you won't run into it as well, but that's an easy fix if you watch what we're doing here. When I write this 2 in, it's very important that I use parentheses. If that were a -2, -2 squared is +4. But if you do not put the parentheses in your calculator will tell you that it is -4. Your calculator is not wrong, you are. Because when I put this in my calculator is going to observe the order of operation, and the order of operation is to square first. Exponents come before multiplication. So it squares the 2 and calls it 4, and then it puts a times -1 on it. That's why your calculator, which is not wrong, but that's why you will get an incorrect answer. It's a real easy fix. I just take my -2 and put it in parentheses. We do not have a -2 here, but I want to make sure that that is something that we are very aware of. All right, same thing. Follow the order of operations. This is not typing, writing, or reading. We do not go left to right, top to bottom. We have an order of operation. Jim Doss, we do not have any grouping. We do have an exponent, which is 2 squared, which is 4. We do have multiplication. 4 times 4 is 16. 3 times 2 is 6. We do not have division. We do not have addition. Now, multiplication and division happen simultaneously. So if division happens first, then you do division first. Adding and subtracting happen simultaneously. So if you have both, do the one that is left to right. That's the exception there. So we have 16 minus 6, which is 10. And 10 minus 4 is our answer, 6. Now, the way that we would denote this, if this was written in a function form, is f of 2 equals 6. What that means is when I used my function and plugged in the number 2, the result was 6. All right, you have the rest of this delta math. Good luck.